So, Namaskar to all. In this second session of water treatment, we will see what are the consequences of hardness of water. In the last session, we have seen that hardness of water is due to dissolved salts. All the salts of calcium and magnesium causes hardness to water, and the foam forming ability of water is decreased, because if you add soap to such water, hard water, much of the soap is consumed in removing hardness first, and therefore the soap consuming capacity of water is also called as hardness of water, depending on how much soap it consumes because of the hardness. The hardness of water is having some serious consequences in industrial use. When we use the hard water which is having high concentration of dissolved salts in industrial operations, then it causes the scale formation. The scale formation is observed even in our home cooker that we use to cook the food. If you see the bottom of that cooker, which is used for say 1 or 2 years, then at the bottom there is a hard eggshell like scale is formed. That is because of the continuous evaporation of hard water into the cooker. Even any container which is used for boiling water repeatedly, that also shows such scale formation. So you can imagine, if small quantity of water evaporated in a container repeatedly causes such scale, what will be the uh, intensity in the large scale boiler like container. So that is one of the issue, and the scale formation reduces the efficiency of boiler. It reduces efficiency because scale is bad conductor of heat. Therefore, extra energy is required to boil the water, and extra energy means extra fuel is required, and extra fuel is required, that means that directly affects on the economy. Further, repeated extra heating of such boilers weakens the boiler metal. That is another issue. And when such weakening occurs, that boiler metal becomes weak, then cracks develops. In cracks, the water goes, when it is converted into steam, it can explode the boiler, and that causes serious hazards. Accidents and failure of metal bodies of boiler occurs many a times. So these are some of the issues uh, why hardness of water needs to be addressed on priority in industries. Now, as we see earlier, the hardness is due to dissolved salts. This hardness is due to dissolved salts of calcium and magnesium. If they are bicarbonates, then it is called as temporary hardness. If they are sulfates, chlorides, etc., then that is called as permanent hardness. Because calcium bicarbonate and magnesium bicarbonate is removed or converted into the carbonates on boiling and cooling down, and these carbonates are having less solubility and they separates down at the bottom, that can be removed. and therefore the bicarbonates are called as temporary hardness, whereas the sulfates, chlorides are called as permanent hardness. Now, these salts, which are chlorides, sulfates, and nitrates of water, of calcium and magnesium, they cannot be removed even after boiling and cooling down, and therefore you have to remove those by addition of certain chemicals. And even if the bicarbonates can be removed by uh, boiling and cooling down, on industrial scale it is not possible to boil and cool that much quantity of water which is obtained from some river like source. Therefore, because that boiling and cooling at boiling point requires a lot of energy, and energy means fuel, and that directly affects the economy. Therefore, the best treatment that is done to the water is lime and soda treatment. So initially, the water which is collected from some raw source, that is filtered, that is allowed to settle down, sedimentation, then coagulants are added, then further whatever fine particles settle down, those are removed, and after that whatever clear water occurs, that water is treated with lime and soda. Even after sedimentation, coagulants can be added together with lime and soda. Lime is calcium hydroxide chemically, and soda is sodium carbonate, that is called as soda ash. These two chemicals are mainly responsible for the lime soda process, where these two chemicals reacts with the temporary as well as permanent hardness to remove the calcium and magnesium in the form of calcium carbonate and magnesium hydroxide. Like, say, calcium bicarbonate, if it is treated with lime, it converts the lime into calcium carbonate. Now this calcium carbonate is insoluble and this settles out. In fact, it should be twice H2. So this is the reaction of calcium bicarbonate with calcium carbonate. Similarly, magnesium bicarbonate, the magnesium temporary hardness, that also reacts with lime to give magnesium hydroxide. It also gives calcium carbonate and water. So like that, the calcium and magnesium temporary hardness is removed by using the lime. You can see that lime reacts with calcium bicarbonate to give calcium carbonate, and lime reacts with magnesium bicarbonate to give magnesium hydroxide and calcium carbonate. Both of these two settle down. Similarly, the species which causes permanent hardness, like, say, calcium chloride, that reacts with soda to give calcium carbonate and sodium chloride. Similar reaction can be written for the calcium sulfate. So calcium sulfate also reacts with sodium carbonate to give calcium carbonate, and Na2SO4 is formed. Now these two species, the salts of sodium, they do not cause scale. Sodium salts do not cause scale. Further, their solubility is very high and they remain in water for long time and they do not form any scale. Therefore, the calcium permanent hardness is converted to the sodium salt, whereas calcium carbonate is deposited. We can write the similar reactions for magnesium chloride. That also sorry, for magnesium chloride, that reacts with the calcium hydroxide to give magnesium hydroxide plus calcium chloride. And similar is the case for magnesium sulfate. It reacts with calcium hydroxide to give magnesium hydroxide plus the calcium sulfate. So in all, the magnesium permanent hardness after reacting with lime gets converted into magnesium hydroxide, which deposits down, and a calcium permanent hardness is formed, and this calcium permanent hardness can then be removed by using soda ash. So in all, to remove a magnesium permanent hardness factor, the salts of magnesium with chloride and sulfate can be removed by using one lime and one soda ash. Thus, the product will be magnesium hydroxide and calcium carbonate along with the salt of sodium, which will not cause any hardness. If the water is acidic, then that also consumes the lime. So HCl, if present in water, that gives calcium chloride plus twice H2O. That means again you require a soda ash to react with the calcium chloride. Similar reaction can be written for H2SO4, but uh, uh, the chances of direct presence of HCl and H2SO4 are less. Usually, such thing occurs where some mine drainage etc. is there. Otherwise, the general hardness in water is out of the calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate, or bicarbonates, and these are the major contents in terms of chemical species. Now, how to remove these salts by using lime and soda? So, actual lime and soda process can be carried out in two ways. One is cold process and another is hot process. Either it can be carried out at room temperature, or, or it can be carried out in presence of some steam. We will see a cold lime soda process where you can see that there is a simple container which is resting on a stand. So this is a steel container which is resting on a steel stand, and this container is having inlet from the top. This inlet, you can see the chemicals written here is soda plus lime plus coagulants. So these are feed from inlet, and raw water is feed from other side. It goes through a spiral which is having a blade. So it goes down with mixing, and in the container you can see that at room temperature the lime and soda reacts with water, where calcium carbonate and magnesium hydroxide is formed, and that settles down in the bottom. When the complete reaction takes place, then from the wool fiber you can see that there is a uh, partition where the porous material is kept so that filtered water comes up, and the filtered water comes out filtered softened water outlet. From this you will get softened water. Softened water means the water which do not have the hardness. So outcome is softened water, and some other ancillary things are given. Stirrer blade is there to mix the things properly. A driving belt is there, motor is there. Those are the ancillary things, and the schematic mainly contains a inlet for soda lime plus coagulant and a outlet for filtered softened water, and one inlet for raw water to feed. When all of the process is completed and when you get the filtered softened water, after some time the sludge starts accumulating on the bottom, and when it happens the process is stopped, and bottom outlet, sludge outlet, you can see that is open to drain out all the white mud, whatever calcium carbonate and magnesium hydroxide is formed at the bottom. Thus this process softens the water and it minimizes the hardness of water, but that does not mean that it removes the hardness completely. In this process, if you add some 200 to 500 ppm of water having 200 to 500 ppm of hardness, then you can see that the outcome may be 50 to 15 to 50 ppm of soft water. That means the hardness still remains, but the effectivity of process lies in the fact that it removes majority of the hardness compared to the cost involved, because lime and soda, these two chemicals are not that costly chemicals. They are available in bulk and they can be procured in the bags of say 25 kg, 50 kg, and therefore these chemicals are cost effective, and when you can remove the majority of the hardness by using only these two cheap chemicals, the lime and soda process is economically effective, and that is why the first treatment to bulk water that is done by industries is usually of the lime and soda process. So we will stop here. and we will see in the next series of lecture about the hot lime soda process. See you then. Thank you.